Alright guys, welcome to Crown Smart. In this video we're going to find f prime of x of the following using what? Chain rule. Now another name for chain rule is simply function of a what? Function. Sometimes you may be given a question that involves function of a function. Okay, we have a function containing a function. So an example here, look at the first one. We have x plus 2 all square. Now this is f of x. Now this is a function with power containing what? A linear function x plus 2. So we want to solve this using what? Chain rule. Okay, but first, before we do this, let's do something first. Now I can solve this. You can expand this as x squared plus x times 2 is 2x, then times 2 is what? 4x. This is equal to plus 2 squared is what? 4. So if we expand this is what we get. Okay, now using our definition to differentiate this, our definition of differentiation, a n x n minus 1, using this to differentiate this, we have here as what? 2x plus 4, and differentiating, if you differentiate a constant 4, we have what? 0. Remember, we're differentiating it 10 by 10. Now this won't be necessary. Okay, this won't be necessary. You know why? Because you may have a question, x plus 2 raised to the power of 5, and it becomes more exhausting to what? Expand this before differentiating. So it takes lots of work to do this job. So that's why function of a function is being introduced. Okay, so but before then, let's find a solution of this using what? Chain rule. Now my chain rule by definition is given as dy over dx is what? Dy over dx is simply f prime of x. Let me put it that way. F prime of x is what? Dy over du times du over dx. This dot is times. Okay, so we have this as now look, the first thing we do, we're going to use this. Okay, so we say let y equal to what? X plus 2 all square. Now this is a function with power containing another function, so we can say let u and let u equal to x plus 2. So we have that our y is equal to what? U square. Now this brings us back to what? Our first principle definition. So we are going to use this formula to differentiate it. Now using it, we have that dy over du. Remember, this is differentiating with y with respect to what? U. Because y is a dependent variable and u is the independent. Independent in the sense that it can take any value, and y depends on u to have a value. So that's why y is the dependent variable. Example, if I put 1 here, 1 square is equal to what? Okay, let's not use 1. If I put u equal to 2, 2 square is what? 4. So y need u to have that value of what? 4. So this is equal to dy du is what? 2u. Okay, by using that our definition, and then we're going to differentiate this. So this is going to be du dx. So I'm differentiating u with respect to the other variable x. So this gives me, by our definition, we have here as 1, and differentiating a constant will be what? 0. So from our formula, dy dx is simply dy dx is simply dy du. What is dy du? 2u times du dx. What is du dx? 1. This is equal to 2u. But we can't leave our answer like this, so we have to express u in terms of what? X. So our u in question is u is equal to x plus 2. So this is equal to 2x plus 2. And if I expand this, I have this as 2x plus what? 4. Does this look alike? Yeah, it looks alike. So this is f prime, sorry. You see, it gives us the same. So we use chain rule if in case we have something like this, also something like this. Okay, when we have a function containing a function. Now a shorter way of doing this to beat time without doing this let y let u. Okay, now this is the question given. Y is equal to x plus 2 all square. This is the question given, so I will just assume this thing to look like a power rule. Okay, just assume everything here in your mind to be u. So if I differentiate this, I have what? I have 2x plus 2. Now 2 minus 1 will give us 1. Okay, then if I differentiate the inside, remember I'm differentiating the outer function, I get this. Differentiating the outside function gives me this. Now if you differentiate the inside, what do you have? You have what? 1, so times 1. So this is equal to 2 bracket x plus 2. That's the answer. Okay, now let's move over to the next question. The next question there is square root of x cubed plus 4. So square root of x cubed plus, okay, that's 1. So let y equal to this, and let our u equal to, remember this is the outside function, this is the inner function, so it's like a function containing a function, a root function containing what, polynomial. So this is x3 plus 1, okay, that's x3 plus 1. So with this is equal to y is equal to square root of u. Now square root of u, from our other video we saw something like this, square root of x, so we say that this is what, u raised to the power of half. So therefore my y is equal to u raised to the power of half. So my dy du is equal to, using that power rule, we have half times what, half times what, u. Now half minus 1 is what, minus half. So this is equal to 1 over 2u raised to the power of half. Okay, now if you differentiate u with respect to x, differentiate u with respect to x, we have this as, using our definition, we have 3x squared plus, remember that's 0, that's 1, sorry, differentiation of a constant is what, 0, so this is 0, so this is 3x squared. Now our dy dx is dy du times du dx, so this is what, 1 over 2u raised to the power of half times du dx is what, 3x squared. This is 3x squared all over 2u raised to the power of half. So this is equal to 3 over 2. Okay, we can't leave our answer like this, so this is 3 over 2 times, okay, we have x squared all over, what is our u? Our u is x cubed plus 1, so we have this as x cubed plus 1, sorry about this, raised to the power of what, half, which is something as 3x squared over 2 root x cubed plus 1. So that's it. Like I said, you can solve it using the other method, okay? You can solve it using another method. You can first assume this to be this, okay? Let's say this is equal to x cubed plus 1 raised to the power of what, half. Now we can solve it, assume this to be a single value, just assume it to be a single value, and differentiate that single value. We have this as x cubed plus 1 raised to the power of what, minus half times what, half, times, okay, sorry, times, now differentiate what is inside, you have 3x squared. So that's a faster way of doing it. It takes a lot of practice. Okay, now we'll move over to the last one. I guess you can do the last one without actually doing let y let u, but I will do both methods. Let y equal to 5x plus 3 raised to the power of 6. So look, expanding this is more stressed, okay? So thank God for chain rule, we'll be able to solve this easily. So differentiating this, like the first thing, I would first use the short way, assume this to be a single value. So this is what, 5x plus 3, that's, I'm differentiating the outside function. So this will be what, bring down 6, and you have 6 minus 1 will be what, 5. Then we are not done. You multiply by what you differentiate inside. So the inside is 5x plus 3. So if I differentiate it, I have what? Differentiating 5x, I have 5. Differentiating 3, I have what? 0. So this is equal to 5. So multiplying these two, we have what? 30 times 5x plus 3 raised to the power of 5. Okay, we can still use our let y and let u, okay, and get the answer. So let y equal to this as usual, and let our u equal to what? 5x plus 6 plus 3, sorry. So so my y will now be y is equal to u raised to the power of 6. So my dy over du is equal to 6u raised to the power of what? 5. And my du over dx is equal to what? 5. Now from the definition, dy du times du dx is what? Dy dx. So dy du is what? 6u5 times what? 5, which is what? 30u5. Now we can't leave our answer like this, so this is 30 into, what is our u? Our u is 5x plus 3 raised to the power of 5, and that is our answer. Thank you guys for watching this video. I hope you enjoyed this video. Please don't forget to subscribe, share to your friends, and like it. Thank you.